I saw that. Okay. Creating test plans. Much as with your architecture, I'm giving you a week to create test plans for a project you've only been working on for a few weeks, okay? I'm not expecting great detailed things. If you want to look at examples of test plans, I recommend you go to the wiki for the prior semesters and look at some of the ones submitted there. Theft is perfectly permitted. In fact, encouraged. It's the highest form of reuse is reusing your deliverables. You'll find in software engineers you will reuse deliverables and shell scripts far more than you'll ever reuse code. Maybe you reuse little codes, but the bigger a piece of code is, the less likely you are to reuse it. Because you run into the problem, I'm off on a tangent here. Here's a problem with code reuse. The problem is the more general the code is, the less suited it is to any specific implementation where you might use it. The more suited it is to any specific implementation you might use it, the less reusable it is by any other implementation. That's the conundrum of code reuse. Code reuse was a big thing in the 90s. And it turned out largely to be a flop. Now, it sort of lives on in service-oriented architectures, microservices, and so on, which try to narrow domains sufficiently small and say, we have this microservice, it's going to do X, Y, and Z. But I know of one company in town that decided they were going to go to a microservice architecture, and their first pilot microservice was going to provide some relatively simple information out of the customer database, and it took them a year to finish it. I don't know all the details of why it took them a year, but that shouldn't have taken a year. It should have taken about 2 weeks. Anyway, what is software quality assurance? It is the red-headed stepchild of IT. It is the first thing to be cut. It is the thing that is funded the least, that is given the least time, and it is where most projects fail. It's a bit like someone is building an airplane and they simply say, slap all the pieces together and weld them, and it'll fly just fine. And then they go through and try to fix one thing at a time. That's how a lot of software gets built. That's why a lot of projects don't fly. Now, it applies not just to the source code, but all your other deliverables. In other words, the things that you want to do in terms of determining quality apply to all the deliverables that you create. How relevant, how accurate, how useful are they? And I have a quote there by myself, which I assume you can read. You should have read it by now. Changing slides. If not, slides will be up on the line. Okay. Core quality values in software. And again, all the slides will be up there. Of course, lecture will be too. The first three are sort of the key ones. Functionality, reliability, performance. Does it do what I need it to do? Does it do it with the minimum of errors? And does it do it in the time necessary to get done? Any one of those three, a failure to achieve any one of those three can render software useless. If I write the world's best word processor and there's a 2-second delay between when I hit the key and when the letter appears on the screen, no one's going to buy it. Or if it's blindingly fast, but the wrong letter shows up on the screen 5% of the time. Even just 1% of the time, especially 1% of the time. People aren't going to buy it. Or if, if I type the keyboard and no letters show up, no one's going to buy it. But you also have to deal with compatibility. How well does it work with other systems? How long will it continue to work? How do I get it out to the people who are going to use it? How much is it going to cost to support? And what's the overall cost of the system? If I, Star Citizen. How many units Star Citizen? Yeah, oh yeah. What's the current Kickstarter total on Star Citizen? Something over $100 million. I'm sorry. That's And it's been going on for 7 years? Okay. Star Citizen is basically like, Sundog on hyper steroids. Individual, open universe, doing stuff. There are a number of games on it. I mean, you play No Man's Sky. Yeah. I do too. Anyway. But my gosh, this thing reeks of failure. It has been dragging out for years. It's burned through vast sums of money. And everyone keeps saying, it's going to be so good when it comes out. And I keep saying, trust me on this. It's not. Sun Tzu says, no good victory ever took a long time. I think that applies in game development. Yes, Jenna?
Yeah, just one comment on that. The weird thing about Star Citizen is that even the people who bought the game, pre-ordered it, have a sunk cost fallacy at this point.
Oh yeah.
They keep buying things, so it's going to.
Well, we're gonna put more money into the Kickstarter. We're gonna buy these expansion things. Anyway, I'm sure I had the cost has to justify what you're actually doing. Now, is $100 million too much to develop a computer game? No, there's actually some of the major computer games that are out cost $100 million and they grossed $500 million on their opening weekend. So with the right model, the cost can be worth it, but you have to make sure that the cost is actually worth it. Okay. Now, I hope you can all see that. This is a chart I came up with back in '96 or so at my time at Fannie Mae, and they were big into adopting object technology, and some of the upper management that said, it's object technology, we don't need to do testing. And I was kind of like, so I did a white paper for them. Said, oh, actually, you need to do testing. In fact, if anything, you need to do more testing because you're juggling razor blades, so you have more things you can do. And I ended up coming up with this model for software quality. Now, the whole point of this is not tied to any particular methodology. And I call this inside out. I tried basically to reverse the whole concept of testing this little bubble at the end of the project when you're testing. It's like, no, you want to do all of your quality assurance activities all the time, thus presaging CI/CD and automated testing by 20 years. So what affects your quality? Your methodology. Well, here you have your process activity. Process activity is creating a new deliverable or modifying an existing one. Whether that's your org chart, your PERT Gantt charts, your architecture, your requirements, your test plan, or your source code. What goes into that? Well, existing deliverables. Either you're revising an existing deliverable or you're using, hopefully, a template for your new deliverable. Guidelines and standards. Expertise, people who are actually good at this particular process. Your organization's key values, the methodology you're using. And you have your process activity, and you end up with a new or modified deliverable. And then you evaluate it as appropriate with metrics and or reviews and or testing. Metrics being automated, objective, and actually useful. Reviews meaning human eyes looking at it and judging it, and testing meaning whatever test is applicable. With all that, you evaluate how good a job was done. You file defect and feature requests in the defect/feature management system. How many of you ever used a bug database? Very few. You get out there, if you're in a good organization, you'll have bug databases so that when you find a defect or there is a feature request, they go into the same database, and there they get evaluated for priority. You do things better, and then you keep everything in a configuration and release management system. This reflects best practices, in my opinion, he said modestly. And what you will find is when you see a problem in a project, or an environment, meaning a particular project team or something like that, you can almost always trace it to some failure in all the surrounding boxes. They lack the expertise. They have no guidelines and standards. The methodology is inappropriate. There are no key values. They're not keeping track of defects. They're not doing metrics. They're not doing reviews. They're not doing testing. And they have no configuration of these management systems. I did as an expert witness, testified in a case. This was for a ERP installation by a third-party firm. They had developers all over the world who were writing, they basically with ERP software usually are doing configuration of existing files that is adapting them specifically to the user, or you're writing custom code as well. There's interface, other systems that have to interface with, or specific adaptations. They had dozens of programmers working from all over the world, and there was no source code control system. All source code updates were being emailed around. No GitHub, there's free source code control systems. They were sending stuff around in email. And so you ended up with multiple versions. You ended up with stuff that wasn't getting delivered, and no one really had control over the source code. It failed for a lot of other reasons, but that was one where I basically, I think I actually said this in court, I said, that's professional malpractice. I mean, in Pages, when I was building an engineering team for class, first person I hired was my sister, and then I hired Bruce Henderson, and at that point we set up a source code control system. Three of us sitting in an office, it's like, we're going with the source code control system. We are managing our code. And and that was 25 years ago. There's no excuse for it. Actually, it's almost 30 years ago. That's scary. It is, 29 years ago. There's no excuse for not having source code control and configuration management. Okay, so we actually talked about all these. You can read the slides. Types of testing. Correct. Yes. Oh, you're just stretching, yawning.
Although, if it makes it feel better, that's still less time than how old my old brother is.
Oh, you mean the 29 years? Yes. No, I'm old. That's fine. Here's my old person story for the day. When I started my software engineering degree, it was actually after my mission, 1974. All our programming was in IBM 360. We were here in the Talmadge building. The mainframe had 1 megabyte of core memory. Now, here's what you have to understand. People are like, oh, we're out of here. Here's what you have to understand about core memory. Each bit is a single tiny magnetic donut with 6 wires on it. That's required for each bit. A megabyte has 1 million of those little cores in it, all individually addressed by these wires. They expanded it while I was a student here to a second megabyte. It was a box like this, and it cost $250,000 for the second megabyte. Think about that next time you grumble about the amount of memory in your smartphone. Okay, building your test plan. We'll go right back into this. Should tie back into requirements of design. Should check for reliability, performance, and functionality. Should indicate what tests are being done and when they're being done or repeated. What constitutes success? Some form of user acceptance testing, get feedback and input from the team. Now this is due a week from today. I'm going to look at them all. I don't expect it to be finished because frankly you're going to be adding to your test plan all through the rest of your project. Either simply ignoring it and doing ad hoc testing. That happens too. There are, yes?
Your slide says Saturday. You said a week from today.
Oh, Saturday. Has to be midnight Saturday. I was wrong. The slide's right. I would go out and look at the prior semester's projects and their test plans and get some ideas. You know, grab a template from one of them and just delete their text and fill it in yourself, or actually keep their text if it's useful. No, seriously, you may look at one and say, well, actually, this is a lot of what we're doing, so we're just going to use this text. That's perfectly okay. That's actually using your head. Types of tests, I'll go back to that. I could give a long lecture on this, I won't. Turn it on. Down at the unit or class level, how many of you already have unit testing set up for any of your software? A few of you sort of do. Cluster testing, basically, if you look, there's levels of testing that you're doing larger and larger groups of software. And then you're trying to do the whole software and saying, is it fast enough? Can it handle all that we need to put through it? Will it work end to end? And when we just change things, does it still work? Regression testing. Again, when we get, in a couple of weeks, get into Accelerate, we'll talk a lot about automated testing and what an advantage that can be done if it's actually being done right. It's possible to do automated testing wrong. That is the end of that lecture. Do we have any questions before the rest of you sneak out? I'll get the videos and slides up. It may take me a day or two. I also have an expert report that I found out over the weekend is due on Friday. So talk to y'all later.